All right, let's do a secant example. So, got a nice funky formula here, a little bit annoying. So we go through the usual routine. We're going to say, okay, -5. So A is -5. B is 4. Since the secant and cosecant are based on sine and cosine, the period's still the same. So you go, oh no, 2 pi over B. So that'd be 2 pi over 4. So the period's pi over 2. So that'll be slightly annoying. Uh-oh, the phase shift is also pi over 2. So I'm going to go over here, just like always, and I'm going to put that pi over 2 right there in the center. That's my new center. Phase shift is the new center. We always need to write that. I would write it immediately so that I don't mess that up later. The displacement, that -3, you can write -3, you can write down 3, whatever makes you happy. So the center line is going to be y equals -3. So I would just go ahead and write that right there, y equals -3. Okay, we're going to do the equation of the asymptotes. One of the last things with the range we're going to have to find out after we've sketched the graph. Once again, amplitude for secant, cosecant, tan, and cotan. We're probably not even going to ask you the amplitude for that. Okay, so now it's going to get a little annoying. We got to label the axis. So here we go. So the period is, so I'm at pi over 2, the period's at pi over 2. So if I go pi over 2 spaces up here, so I've got pi over 2 plus pi over 2, so that's pi. Down here, if I've got pi over 2 minus pi over 2, that makes 0. So that's slightly annoying. Of course, on the other hand, it makes it easier to chop it up. What's halfway between 0 and pi over 2 is just pi over 4. That's easy to chop up. What's halfway between here and here? That's 3 pi over 4. That's easy to chop up. A little bit trickier now. Pi over 8. So it looks like we're increasing by increments of pi over 8. Plus 1 pi over 8, so that's 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8. So there you go. So the y is -5. That's -3. So we're going to go up 5 spaces. So if I start at -3 and go up 5 spaces, that puts me at 2. I go down 5 spaces. So if I'm at -3 and I go down 5 spaces, that's going to put me in -8. Okay. So like we said, we're going to start out by graphing a cosine. We're going to pretend it's cosine. When we do a secant, we pretend it's cosine for a minute. So let me see. Cosine. Negative cosine. Let me see. Sine curves always start in the center. Cosine curves either start at the max or the min. Negative cosine starts at the min. So my first point is going to be right here at the min. Then it's going to go to the center, then up to the max, back to the center, and then back to the min. So over here, we go the other way. And hopefully at this point, you're starting to think, hey, no big deal. I can put these pieces together. So there you go. You just graphed a cosine curve dotted. And by the way, I'm going to yell about this in class. Make these dotted. Do not make this a solid line. Because if you make this a solid line and then you make your other curves solid, I'm going to be all confused and not know what to grade. So you got to make these guys dotted or really super light. Once again, we're in the same situation though. Wherever the cosine curve crosses the center line, the secant curve doesn't exist. Okay, once again, you say, I don't believe you. That's crazy. Okay, let's prove it. Let's take one of these guys, 5 pi over 8. Let me see, 5 pi over 8 minus pi over 2. So that'd be 4 pi over 8. That makes 1 pi over 8 times 4. 4 times pi over 8 is 4 pi over 8, which makes pi over 2. What's secant of pi over 2? Secant of pi over 2 does not exist. So this does not exist. So where it crosses the center line, where the cosine curve crosses the center line, the secant curve does not exist. So this is where we get our asymptotes. So I know this is a little bit more annoying, but not too much more annoying. Then we do the same routine. We just do our flip over. There's something weird about this, though. We do our flip over. So you say, okay, they've got the max min in common. Then they just flip over. Got the max min in common. Then they just flip over and they stay inside the asymptotes. Every year we do this, people draw the curves outside the asymptotes. You cannot cross those asymptotes. Okay, now, these pieces on the end, these look kind of funny because you're thinking, well, if it flips over, it has to just flip over like that. So it's only a half piece. Same thing down here. It flips over like that. It's this guy flipping over, so it's only a half piece. Okay, here we go with our asymptote formula. Okay, so as we know the asymptote formula is x equals, you pick any asymptote plus n standing for integer times half the period. So the period divided by 2. Well, if the period is pi over 2, half of that is pi over 4. So our asymptotes are, so if we just pick an asymptote also off of here, somebody says, well, I'm going to pick 3 pi over 8. Somebody else says, I'm going to pick 5 pi over 8. It doesn't matter. It does not matter. I'll have a list of possible answers here that I would grade. So I'm just going to put 3 pi over 8. It does not matter. Okay. And then half the period was pi over 4. So n times pi over 4. So there's your equation of the asymptote. Oh, the range. Haven't done the range yet. So the range would be negative infinity to that negative 8. So negative infinity to that negative 8, inclusive, because that point is included, union, where does it start over again? 2 to infinity. And then, like I keep saying, the very, very last step, I would make the y-axis the very last step. I know there's always people that are going to be contrary and not do that, but if you put the y-axis on there too soon, it's going to throw off the symmetry. So anyway, there you go. There's a secant example with all the stuff we're going to expect you to be able to do. Okay. All right.